Now what do you mean by electromagnetic spectrum? Arrangement of electromagnetic radiation in order of increasing wavelength. We can see here radio waves, microwaves, IR, infrared, visible, ultraviolet, X-rays, gamma rays and cosmic rays. Like this the increasing order of wavelength. Limitation of electromagnetic wave theory, it could not explain the phenomena of black body radiation and photoelectric effect. What is black body radiation? We are observing it if substance being heated in a black body is a black body which is perfect absorber or perfect radiator of energy. The radiation emitted is only called black body radiations. Okay. Or what is photoelectric effect? If we are talking when radiation with frequency greater than certain minimum frequency is emitted, strike the surface of metal, electrons are ejected. Okay, and this minimum energy is only called work function. So that effect is called photoelectric effect. Now what is Planck's quantum theory? So this theory is put forward to explain the limitation of electromagnetic wave theory, such as the radiant energy is emitted or absorbed discontinuously in a small packets of energy called quanta here. So called photons in case of light. Light energy is called photons and otherwise it is the energy packets are called quanta. Okay. Energy of each quanta E is equal to h nu, where the h is a Planck's constant. Planck's constant value is always fixed, 6.626 into 10 power minus 34 joule second. Total energy emitted or absorbed, where n is an integer. If n is equal to n naught, energy is called 1 Einstein. Okay. Now what is explanation of photoelectric effect? When light falls on the metal surface, energy of photon is absorbed by the electron. Electron is dislodged from the metal only when the energy absorbed is more than the minimum energy. Okay. Threshold energy is required to overcome its force of attraction. The difference of energy is imparted to the electron, its kinetic energy. So what is kinetic energy? 1 by 2 mv square here, or we can say hv is equal to hv naught, or hv is equal to hv naught plus 1 by 2 mv square, which is equals to w naught plus 1 by 2 mv square. So as energy of photon depends on frequency and not on intensity, increasing the intensity of light to particular frequency increases the number of electrons ejected but not their kinetic energy. We were doing electromagnetic dual nature of electromagnetic radiation. So interference, diffraction and can be explained if light has wave nature. Okay. So photoelectric effect can be explained if light has particle nature. Hence light is said to be having both nature, dual. Dual means it has wave as well as particle. So the moment is like wave and the mass is like particle, correct? So that is why this concept is put forward by Einstein. So electron volt, EV of energy. What is that? Energy required by an electron under a potential difference of 1 volt. What is we are using this unit, so we should know what is electron volt. Energy acquired by an electron under a potential difference of 1 volt is called electron volt. So 1 electron volt is 1.602 into 10 power minus 19 of joules. Okay. Then emission and absorption spectra. There are two types of spectra, emission and absorption. Now for any spectra, the basic principle and basic behavior will be, we are using a source and from that source the radiations will be passed, that they will be passing on the prism. Okay, source of light means they will be passing through the prism. When they passing through the prism, it will get scattered, it will be captured on photographic film. So photographic film, what you get fine lines or you get bands. So it depends on that type of spectra. Okay. Now when light is emitted from any source, we have taken light, a light source is directly passed on the prism and resolved. The spectrum obtained is called emission spectrum. Okay, like here, suppose you have a source of light here. Light is passing through the fine slit here and it is passing on the prism. And it is captured on the photographic film. Okay, so these are the way we can do it on the photographic film. What we get, that is called spectrum. Okay, so here emission spectrum, in case of white light from sun, it is resolved to 7 colors. We begin 7 colors. What are the 7 colors we have here? We will see. All of you are familiar, but still we will just V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. Like this is called Vibgyor. Okay, so according to wavelength it is arranged. Then we can say the spectrum obtained is called continuous spectrum. Continuous spectrum. Okay, and then if light emitted from a discharge tube is evolved, some color lines are obtained. The spectrum obtained is called line spectrum. Okay, and if white light is first passed through solution of a compound or vapors and then substance and then resolved, the spectrum is obtained is called absorption spectrum. So there are different type of spectrums which we have discussed here. We have discussed here about the continuous spectrum, emission spectrum, line spectrum and absorption spectrum. Okay, so it has dark lines in continuous spectrums. You are getting bands. So like absorption spectrum of hydrogen is when hydrogen gas is taken in a discharge tube, series of lines are obtained and the region in which they lie as under. Now different scientists has discovered and studied about that lines. So to give respect to them, the name behind the lines is given. So these are the name of a scientist: Lyman, Balmer, Paschen, Brackett, Fund, okay, and Humphrey. So these are the different series. Now which region? Only Lyman series is obtained in ultraviolet region. Balmer series is obtained in visible region. All of you know what is visible region. The human eye can see 400 nanometer to 800 nanometer region wavelength, and that region is only there are 7 colors and the shades of 7 colors which human eye can see. Below that or above that we cannot see. So that like microwave radiations are there, or infrared radiations are present. Using some special instruments we can see them, but by human eye, naked eye, we cannot see. We can see only visible region. That is called visible region because in that region we can see the 7 colors and the shades. Okay, so visible region, then all these are obtained in infrared region. Okay, then what is Rydberg formula? This formula is specifically called Rydberg formula because it is given by a scientist named Rydberg, and this formula is to calculate wave number of different series of line in the spectrum of hydrogen and hydrogen like particles. So this is wave number is equal to R. R is a Rydberg's constant, 1 by n1 square minus 1 by n2 square. N is the energy level, okay, and Z square is a Z is 1 for hydrogen. Z is atomic number. So where R is the Rydberg constant, what is the value of R? 109677 centimeter to the power 4 or 1.097 into 10 power 7 meter inverse. So for Lyman series we will take it is in the first energy level. So N1 is equal to 1, N2 is equal to after that 2, 3, 4. So for Balmer series N1 is equal to 2. So another N2 will be after that 3, 4, 5 like that. For Paschen series 3, so 4, 5, 6 and so on. So when N1 is equal to 2 like Balmer series, so the formula is called Balmer series formula. Okay, so drawback of Rutherford model, there are few drawbacks also. Revolving electron will lose energy continuously. We are saying ki electron is constantly moving around the nucleus. So any particle when constantly moving, it will be having loss of energy. So when they lose energy continuously, hence its orbits become smaller. So it should come to lower energy, then further lower energy, electron should transfer, and like that at one point of time it should have completely loss of energy, so it should fall into the nucleus, but actual practice it doesn't happen. Okay, so become smaller and smaller following a spiral path, and ultimately fall should be into the nucleus, and atom should collapse, because if the electron falls into nucleus, atom will collapse, but actual practice it does not happen. Okay, why? Because it could not explain line spectra of hydrogen atom, it could not explain line spectra, it could not explain why it does not fall, why it is constantly moving, because there are two forces acting upon, one is called centripetal force and one is called centrifugal force. So one force which is taking electron towards, pulling electron towards the nucleus due to positive charge in the nucleus, and another force which is making electron away from the nucleus. So both the forces are equal and oppositely acting each other, and the counterbalancing will happen. Like that the electron is keep revolving, it does not fall into the nucleus. So that is not been explained by Rutherford model. Now Bohr's model is required to explain the above drawbacks. Bohr postulate that electron revolve around the nucleus only in those orbit which has fixed values of energy. So near the nucleus lesser energy, then higher like that. So these are called stationary states. Again I will tell, a stationary state doesn't mean electron is stationary. Electron is not stationary at any place. Electron is a moving mobile particle only. Stationary is the energy level. Of that level energy is fixed. That is called stationary state. So they are numbered as 1, 2, 3, 4 or KLMN, and energy of nth orbit like hydrogen like particle, if we say, that is for En is equal to minus 2 pi square me to the power 4 n square h square into z square, where here we are having charge of electron, mass and charge of electron. If we talk, substituting the values, we have here minus 2.18 into 10 power minus 19 by n square into z square joule per atom, and you are getting minus 13.6 n square electron volt per atom, okay, or the final value minus 1312 by n square kilojoules per mole, okay. So radius and velocity of nth orbit can be Rn is equal to a naught n square by z, Vn is equal to v naught z by n. So what is a naught here? A naught is Bohr's radius of first orbit of hydrogen atom, and v naught is velocity of first orbit, okay. Like energy, angular momentum also have a quantized value given by mvr is equal to nh by 2 pi, okay. So it should be momentum, it should be, and lowest energy state of an electron is called ground state, okay. So ground state is the first state, the lowest naturally existing state. After that, when it absorbs energy, it jumps to the higher orbit, and that is only called excited state. How much energy is absorbed, accordingly the jump will be there, okay. So jump will be 1 orbital or more than that, that depends on the absorption of energy. Then when it jumps back to lower orbit, energy is released. Energy absorbed or released can be calculated by delta E, which is E2 minus E1, final to initial. Now electronic energy as a negative energy, if we talk, when electron is an infinite distance from nucleus, there is no attraction, so its energy is taken as 0. When it comes closer to the nucleus, attraction takes place, so energy is released, hence it becomes negative. So that is why this electron energy value is always negative, the reason for this, okay. While large number of lines appear in hydrogen spectrum, electron absorbs energy and jumps to different outer orbit energy levels, then they start jumping back to different inner orbits, okay. So each jump releases energy, so delta E is equal to h nu is equal to hc by lambda, therefore producing a line with lambda is hc by ae. So number of spectral lines produced between two levels, it is n2 minus n1, or it can be given as delta n. For transition between level 4 and 1, lines produced can be here 3 plus 2 plus 1, it can be 6 lines. That is why more number of lines are produced, okay. Now de Broglie concept of dual nature, just as light has dual nature, every material particle in motion has dual nature, okay. So what do you mean by dual nature? Mass like particle and moment like wave. So particle nature, wave nature, relation between them is only called de Broglie's relationship. De Broglie's relation is lambda is equal to h by m nu, okay, or we can say h by p, where lambda is a wavelength, m is mass, and v is velocity, p is momentum of the material particle. Although it is applicable to all material objects, but it has significant value for microscopic particles. Like the wave character has been verified by Davison and Germer experiment, whereas particle nature by Scintillaon experiments, okay.